So our objective in this lesson is going to not only be to use what we learned with side, 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 angle, 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 side, and hypotenuse leg, but to also use something new called CPCTC to prove that parts of a triangle are congruent. So we're not proving that the entire triangle is congruent. Now we're just proving that parts of the triangle are congruent to one another. So what does CPCTC stand for? It stands for corresponding parts of congruent triangles are congruent. The C stands for corresponding, P, parts of, C, congruent, triangles are congruent. So if we prove two triangles are congruent, then we can say that any corresponding parts in that triangle are also congruent. So CPCTC. So let's have this triangle here. We can prove that this triangle is congruent by the angle-side theorem. Why? Because we know that angle P is congruent to angle Q. We are also given that angle PRS is congruent to angle QRS. So those angles are congruent. And then the last thing we know is that side RS is congruent to itself by the reflexive property. So that side is congruent to itself. So we can say then that triangle PRS is congruent to triangle QRS by the angle-side theorem. So that's where we would have left off had we just done section 4.4, 4.5, 4.6. I'm sorry, 4.4 and 4.5. But now that we're doing section 4.6, let's say our goal was to try to prove, oops, I was about to write the word proven, to try to prove that segment RP was congruent to segment RQ. That's what we wanted to prove. Now that we know that triangles are congruent, we can say this is true because corresponding parts of congruent triangles are also congruent. Corresponding parts of congruent triangles are congruent. So when you're using CPCTC, the very first thing you want to do, and change the color for emphasis, the very first thing that you want to do is prove that the triangles are congruent. Prove triangles are congruent by ASA, AAS, SSS, SAS, or hypotenuse leg. That's the first thing. And then once you know the triangles are congruent, you can prove or you can show that corresponding parts are congruent because, corresponding parts of congruent triangles are congruent. So that will be the only justification you need. RP is congruent to RQ as a result of knowing that the triangles are congruent. PS is congruent to QS as a result of knowing that they're congruent. And PSR is congruent to angle QSR because the triangles are congruent, because corresponding parts of congruent triangles are congruent. So we're going one step further. Prove the triangles are congruent first, and then show that the corresponding parts are congruent because the triangles are congruent. So here we want to find out what the length of AB is. How wide is this lake? Or ravine, maybe I should say. A and B are on the edges of a ravine. What is the length of AB? Well, if I want to say that AB corresponds to another part in another triangle and say that they're the same, then first I have to prove that the triangles are congruent. So let's call this ABC, and let's call this D, and this E. So the first thing I want to do is show that triangle ABC is congruent to triangle. So let's see what would correspond with A. It would be E, and then D would correspond with B, and then C. First, I want to show that those two triangles are congruent. That would be this triangle here is congruent to this triangle here. Okay, so that's the first thing I want to do, is show that those two triangles are congruent. Well, I notice I have some congruent angles. I know that this is 15 and that's 15. I know that this is 10 and that's 10. So it would be necessary to say that first, I know that BC is congruent to CD because they're both 15. I know that AC is congruent to CE because they're both 10. And I also know that this angle is congruent to this angle. So angle ACB is congruent to angle ECD by the vertical angles theorem. So now I know that the triangles are congruent. So therefore, triangle ABC is congruent to triangle EDC by the side angle side postulate. So if the two triangles are congruent, then I can say that means that DE is the same as AB because corresponding parts of congruent triangles are congruent, is congruent to AB by CTCTC. Corresponding parts of congruent triangles are congruent, and therefore these little 3 marks in math means therefore the length of segment AB is 18 miles. We know that that is the length of the ravine, or the width of the ravine. Okay, so this is a very informal proof. Very informal proof. Okay, so here's another one. This is more generic. We've got YW bisects XZ. So as a result of that, we know that YW bisects XZ. So because YW bisects XZ, that's going to mean that these two segments are congruent by definition of a bisect. And we also know that XY is congruent to YZ. So XY is congruent to YZ. Okay? Now, I'm trying to prove that these triangles are congruent. So we know that we have 5 things we can use. And so I'm thinking because YW is congruent to itself, we can use the reflexive property and use side, side, side. So we've got our statements here and our reasons. And I'm first going to put YW bisects segment XZ, and that is given. And now because of the definition of a bisector, we can say that segment XW is congruent to WZ by definition of a bisector. Then next we have, let's see, we were given that XY is congruent to YZ. That was given. And we can say that YW is congruent to itself by the reflexive property. And it's reflexive property, not reflection property. I've heard people saying that in class. So then 5, we can say that triangle XYW is congruent to triangle ZYW by side, side, side postulate. And if those two triangles are congruent to each other, then that means the corresponding parts are congruent. So your last step would be angle XYW is congruent to angle ZYW, and your rationale or your justification or your reason would be CPCTC. Corresponding parts of congruent triangles are congruent. Okay, I want you to try this proof on your own. Take a look at it, try it, and bring it to class tomorrow. And then we'll go through that in class tomorrow.